Well, we're back in the garage, and the last video was pretty cool. Went to VIR. I was supposed to be taking this thing, but I really don't want to rush this thing. I've had way too many failures in the 2023 season when I was going for a championship run. And after disassembling the car, and especially going through the electrical, I was like, now I know why I had so many issues. A lot of it was just kind of hacked together. So this car, we did all custom wiring. We moved all of the fuse box onto the right side of the car, so that required extending the harness over. We redid all of the kill switch wiring, all of the battery wiring, all of the starter wiring, all of the fuse box wiring. We had to redo headlights. We had to do so much in this car. So as a result, when I put it back together, I wanted to make sure that everything was working correctly. I was seeing this issue in my car where cam 0 and cam 1 and crank, they provide a a duration signal. That duration was pulling low. So I talked to Jeff Evans at Evans Tuning. I'm actually a subscriber for his Evans Tuning Performance Academy or something like that. It's like $50 a month. It's a lot of money, but it's well worth it because if you go on his forum, he'll respond to little issues that you have and stuff like that. He said that it's not an issue. I talked to Leland Wambolt, who is the 2023 regional champion in Northeast H2. And so he said, yeah, I've never used that duration signal ever in tuning a car. I still wasn't satisfied though. So I uploaded the data into ChatGPT and I said, here's my CSV. Tell me whether you think that the cam phase pulling or the cam duration pulling low is an issue. And I gave it the engine speed and what that equates to in a revolution, and the cam is supposed to spin at I think half of the speed of the crank, and got it down to tenths and hundredths of a second, and ChatGPT was essentially like, no, I think it's a scan rate issue with your ECU. So I still didn't believe it, and what I did was I started going through Evans Tuning's logs again, not his logs, but his videos, and he has videos on diagnostics and I think cam crank signal. And in that video, he showed 3 different examples where cam phase, I keep getting that wrong, was pulling low on a Dodge Viper, a Honda Civic or something, and then I think like a Supra. All 3 cars, all of them. But what he was looking for was start probability being 100%, cam sync being at no errors, and then start sync, I think it is, having no errors. Then in addition, while he's revving the motor, he's looking for errors in the camshaft position and the crankshaft position. And then he's also looking for breakups and misfires. So I spent a long time troubleshooting this to try and make sure that it was more or less bulletproof. So we got the Civic here, as y'all know. I dropped the laptop while I was playing with it. I'm very upset about that. The screen is cracked and now the touchscreen doesn't work, so that sucks. We were just looking at Evans Performance Academy. He was going over, this is the variable, this is the cam phasing page. We have a tab for VVC, right? And it has a target for where your cam gear is supposed to go if you have a variable cam gear. The white signal is your target for your cam gear. The orange signal is your cam timing. And you're looking basically to minimize the offset between the white line and the orange line, I think it is. The cam timing and the cam target at idle. So he had to play with some settings to get that right. I think I'm pretty good. And then as you can see, it should be relatively close while you're running up on a dyno pull, whatever. So we kind of did the same thing. So we're going through the logs here. And this is my engine, right? So the orange is the cam position, the white is the demand, and it's overshooting the demand a little bit. That means that the proportional gain is probably a little bit too high. So in industry, in like process automation and controls, there's controllers called proportional, integrative, and derivative feedback controllers. I don't remember what each of the components of that controller stands for in terms of what it does. But basically, if a proportion is too high, I think that it can overshoot the demand signal. We got it. I didn't film it, but we got the the Lambda sensor hooked up. So this is all custom harness. As I mentioned before, that Lambda sensor had to be hooked up to an onboard Lambda sensor on the AEM ECU. The onboard sensor basically has to be selected correctly. So you select your inputs and outputs in the software. And then once you get that selected, it allows the engine to control fuel based off of your air to fuel ratio. So if your air to fuel ratio is too high based off of your target, that means that you have too much air, so it adds more fuel. If it's too low, it reduces the amount of fuel it adds. An issue that I was having was I had this running on a B series map. Now, the reason I had it running on a B series map was because it ran very good on the B series map. But the issue was that I was not getting cam control because a B series does not have a cam phasing feature. Cam phasing is moving the camshaft, advancing or retarded in the rev range, right? This has something called a VTC, I think variable timing camshaft gear, something like that. And that basically controls this intake camshaft to advance or retard it as you're driving the car. So I wasn't getting that signal. I was trying to play with inputs and outputs to get it to work. I said, screw it. I went back to a K20 base map. And then after I did that and I got all the inputs, the correct injectors set in there, I locked the ignition timing up here. I hooked up my trusty timing light to this tiny, tiny little bit of wiring here to get cylinder 1 top dead center. And shine the light down here. Shine the light on me. Shine the light on me. I think that's this little light of mine. I'm gonna let... So anyway, there's a 0 degree before top dead center, which is basically top dead center mark on that camshaft. You lock it there. You set the ignition advance / retard offset in the software. You unlock it, and then the car runs amazing. So that was a lot. So what we have to do now is we have a couple of odds and ends. You'll notice down here that there is a leak. I don't know where there's oil behind there. I have no idea where it's coming from, but it's getting bigger. And I went under the car before and I couldn't find where it was coming from. You can see we have a fried O2 sensor over there. It didn't work. And there's a bunch of water. So surprise, surprise, the eBay thermostat housing down there, you can't really see it. It's got a little temperature sensor sticking out of it. That little black thing is a swivel neck thermostat housing. And it's very common for people with K-swaps to use them because the angle of the thermostat outlet is not aimed correctly for most radiators, right? So I'm gonna write down a list of what we have to do, and I think that's how we're gonna get into this video. So the first thing on this list of things to do was adding in transmission fluid. This is Torco RTF. It's pretty expensive, but I had some Summit bucks from instructing this year. Decided to use those to lower the cost a little bit. Off camera, I had finished some of the wiring for the body harness and for the fuse box, but I had to do additional sensors. So basically, fuel pressure, water pressure, etc. They would be going to an auxiliary connector on the AEM jumper harness, which is what I'm working on here. However, the reason I'm de-pinning it here and labeling all of the wires is because it came with an Amphenol connector, a 12-pin Amphenol. I wanted to swap that out for a 12-pin DT just because that's what this car uses, is Deutsch connectors. And so as you can see, I de-pinned it, labeled all the wires according to where they went in the Amphenol connector, and then put them back into the DT connector. So if it came out of spot 1, it went back into spot 1. But, you know, it would be coming out of an Amphenol and going into a DT, basically. Now, that all may sound fine and dandy, but part of the problem is the pins for the Amphenol connector actually did not fit into the DT connector. So I had to cut them all off with my trusty ancient food scissors from the dollar store, and I had to put on new pins with my ratcheting crimpers and my fancy wire strippers. Crimping terminals on the wires took some getting used to. So you can see here, I'm actually tightening up the terminals with a set of needle nose pliers and then putting them into the crimper as so.
You got to get the orientation right so that, if you're right hand, left hand, want the crimp facing towards you, away from you. But basically to give you the best angle so that when you get the wire in, you're clamping down on the metal with one section of the tab, and then you're clamping down on the wire sheathing with another section of the tab, because there's 2 tabs on the pins. Putting the wires back into the DT connector is pretty straightforward. I'm not really going to go over this. I did mess up this green insert piece that's supposed to go in there, but it still seemed to work. Yeah, then I heat shrunk around the wires and the sheathing for the harness itself, and made sure all of the labels for the wires were hidden up in there. Next, I commenced with figuring out where the wires would go in the car. Fun. So plugging up the adapter harness first and getting some of the wiring harnesses I wasn't ready to deal with out of the way, and then figuring out how I wanted this adapter harness to be set up in the car, basically. So this here is a jumper harness, and the correct way to have done all of this is to make a harness and a PDM. I'm not doing that, as I've mentioned in previous videos. We're trying to do like a hybrid of wiring it correctly and also retaining OEM components while, lengthening, as you can see, all the stuff to this side. So for the most part over here, we're done, right? But what I had to do was I had to figure out where all of the wires were going to sit, right? So like this is not mounted yet, right? This is clearly not mounted yet. This is a jumper harness from Civic Racing that's not mounted yet. That's tape. And so like we got a P bracket here that's mounted to a junction terminal, OEM junction terminal. We heat shrinked, or not heat shrink, but we protected everything. We loomed everything up. So that way it's less likely to get abraded by rubbing against the chassis with all the vibrations. So all those wires behind this OEM fuse box are wrapped up. Now, we left one section of the body harness right here unwrapped because there's 4 wires that need to be attached here to this Civic Racing harness. And then the Civic Racing harness also has to attach to the engine harness. So this engine harness is kind of in the way right now. I guess the correct thing to do would be to kind of like put it up here so it's out of the way. But all of these wires, for the most part, are kind of in their spaces where they're going to go. We're going to keep this jumper harness, and this guy right here, we want to mount it here. Problem is this is square, that's round, right? So what we're going to do is we're going to take angle aluminum, all right, like this, and you'll notice that when you lay it on the tube, right, let's get this wire out of the way, you can make a flat surface, right? So see how that's a flat surface now? But the problem, so we need to basically cut it to length so that it can go, vertical wise on this bar for the pillar bar. I already checked that rectangular connector is actually shorter than the length of the vertical down tube. So we'll cut this, it'll be longer. We can band clamp here. And then there are two unused connections on this right here, and there's also some space at the end, so we're going to basically use tape and just tape it there, and that'll work. Again, not ideal, but we're trying to make it work. We're trying to get this car done, right? So let's get started.
I'm not gonna lie. Oh, you're rolling. At least 10% better. Well, FedEx just came. We got some mail. Some time seem kind of strange to me considering the rest of the truck.
So we started by taking the cut piece of aluminum, mocking it up against the down tube, and then opening up some hose clamps from Harbor Freight and tightening them down to get the flat surface that I needed for my jumper harness. These hose clamps held up surprisingly well, so shout out Harbor Freight. So as I mentioned, my original plan was to just tape it once, right? I I guess it would be perpendicular with the length of the down tube. But what I realized was that even with 2 passes of tape, the sub harness was not, or the adapter harness wasn't as solid as I would have liked it. So I basically redid everything here. This took like 35 minutes or something just trying to get it right. But we taped it parallel now with the length of the down tube first. And then we mocked up the bracket, tightened it again. So then that way it was held parallel. And then we also did perpendicular this time. So this was a lot better. Again, not ideal, but we're trying to make it work, boys and girls.
Well, it's in there. So this side should be the side that the connectors go into, like the script. Yeah. So that way we'll be able to, connect it, click it in from this side. We won't have to reach around, right? And then also you notice that I actually took it off in the video. I talked about this earlier, but basically wrapped it around here, and then the tape terminates underneath here. So this is applying pressure to the tape. And then what I do is I do one pass whenever I'm doing like wiring or trying to secure something with electrical tape. I do one pass real tight, and then I do another pass that's a little bit loose, but I make it really sticky. So I push it really hard. So I don't stretch the tape the second pass around, because if you do the first pass and you stretch it, it'll secure things like wiring, whatever else. But if you terminate it with the tape stretched, the tape will slowly over time come loose. So tight first pass, second pass I do loose, and then I just push it down like that. So I did the same thing here. First pass was really tight to try and get it to, I don't like how that's rubbing against that, whatever.
We got
But
multiple sliders in the RC engine. Primary injectors. Still an O-ring in there, which I'd like to retrieve. So these little injectors are what shoot the crankcase oil into your engine.
So got the big dog in here. Just got finished eating some big dogs, eating them glizzies. I got Tony behind the camera, and so we're back here. We're back. We're here. We're back here. We in here. We outside. We inside. We everywhere. What you know about that? Tony.
What?
Tony, yeah. There we go.
I'm eating my hot dog, man.
Get the glizzy on. So, as I mentioned before, we had a coolant leak. We wrote it down on the list of things to do. So this is a cheap Amazon swivel neck that leaked coolant immediately. Surprise, surprise. So what we're going to do is we're going to put RTV on this side. We're going to put RTV on this gasket here. And then we're going to put RTV in the stationary part of the housing. And the reason I think it leaked was because I tightened this part and then twisted it, which you're not supposed to do. So what I'm going to do is I'm going to get it as best I can into place like so. I have it clocked. And then I'm going to try and potentially take some OEM Honda bolts, because they'll slip in there like that. And then hopefully that'll screw in. I don't think it'll work, though. It might not work. But we can try. We can always try. It might work, actually. It'll be tight, but it'll work. Originally, it comes with these, Chinese specials, Allen Johns. But nobody got time for that. So we got some Permatex, right stuff, Fanta, and we're gonna RTV, boys and girls, because ain't nobody got time for leaks. Let's see, where's my? Should be on the.
Turn your background music off here.
Nah, it's fine. As long as there's no diesel heater. Alright, go ahead.
Holding.
So we did end up RTVing that swivel neck thermostat housing, and then we did also end up using the Honda bolts, and they didn't end up stripping out the base housing that attaches to the water pump. So that was fine. And then the next thing that we had to do was do a clutch bleed, because, well, never did that. Took some time, Tony and I talking back and forth, but eventually it worked out.
video guy is a nerd. Not like us. We're really.
You don't like to talk about spherical bearings?
No, we're not nerdy at all. We never talk about.
Nobody
something like
needs soft bearings. Exactly. or oblong or egg-shaped bearings?
Fuel pre-gain.
Pregnant airline?
Fuel preg air line. Oh, fuel pressure regulator air line.
P-reg, okay.
So we got the additional sensors are not wired in. Oil leak, fuse box, water leak we crossed off. Okay, cool. All right, so we got the clutch bled just now. We got the thermostat housing reattached. This time it doesn't swivel with all the bolts tight, so I think I did it right this time, as opposed to last time when I didn't do it right. But as I wrote on my board earlier, we need to finish up some of the wiring. So I was just showing Tony about some of my like best practices when I do wiring. And I figured, I was like, why don't I just record this on video? So these sensors right here, these are cheap Chinese pressure sensors. The calibration, I have never had an issue with the scale, right? So 0 to 5 volts, 0 to 150 PSI, they're always linear. There's very rarely any drift. There's very rarely any offset. The problem that I usually find is the quality of the connectors is really bad. And then also, I've seen videos, it's never happened to me yet, knock on plastic, but I've seen videos where these fail. So like on brake fittings and stuff, you gotta really be careful when you use these cheap Chinese ones. So I was telling Tony is that when I install the sensors and I'm done wiring them up, I take electric tape and I actually make sure that the cheap Chinese ones are solid. Now the reason I use them instead of using expensive ones is because the expensive ones are like, you can go to low dollar motorsport and get like $50 ones. I'm not really sure if it's worth it though compared to like an Amazon or eBay sensor because the Bosch ones are probably $100 or a little more than $100 each. So, you know, I'm going to have 8 pressure sensors just on the brakes, just in the braking system. I'm going to have fuel pressure, water pressure, oil pressure. So that's 11 times 100 is $1,100. So I use the cheaper stuff. It's always worked well for me. The next thing I wanted to show you guys was, so when I'm making a wiring harness, I use painter's tape. And the painter's tape basically allows me to set up the wires where I need it to go when it's going to be finished, right? So right now it's not finished, but we have this red wire, and that's going to be used to gauge the length that we need. And what it's going to do is we're going to have this thick harness, right, with 3 wires. It's going to be signal, power, and ground. And then this red wire is going to run through that firewall. And we're running water pressure, we're running fuel pressure, we're running oil pressure to an auxiliary input on the ECU over here. So, yeah. You want to see it? It's like right here. This guy, earlier in the video, we were remaking this Amphenol John into a DT John. But yeah, so this 12-pin John, that's going to be able to supply 5-volt power, 12-volt power, sensor ground. And then it takes, you know, coolant pressure, it takes fuel pressure, oil pressure, so all through that auxiliary connector right there.
The next day I went in the garage and all of the wires were pretty much in their place. So I just had to attach, you know, some DT terminals to them and then get them inside of the DT connector. And yeah, pretty much that.
We last night started kind of wrapping everything up in terms of wiring. So down there you'll see that little sensor dangling off. That's the redundant water temperature. But everything is loomed up. So this is water temperature here, right? Fuel pressure, right? Wideband, right? So wideband. This is water and oil pressure, right? Comes out there. And then we actually have everything wired up here. Everything is labeled. So what we have now is we have the USB plugged into the ECU. And then I think that the kill switch is off. I guess it's not getting powered because it's not plugged in. Give me a second. All right, broskies and broettes.
So here's what we got going on here. We got coolant pressure sitting at 0.5 psi, fuel pressure sitting at 34. So there's got to be some fuel left in the system. Oil temperature is actually our redundant water temperature. And then we should have oil pressure, 0.4. So let's take a look. So we're going to go through the wizards. We already checked out that the fuel pressure was good, right? So if you go to fuel pressure, double click it, 0.5 min, 4.5 max in volts, and then it's a 150 psi sensor. So that's good. We go to oil pressure sensor now. Oil pressure is at 0.5 min, 4.5 max volts, 0 to 150 oil pressure, so that's calibrated correctly. Water pressure is at 100. So if we go to additional inputs, which should be input function assignment, and then we go to coolant pressure sensor setup, 0.5 min, 4.5 max, 100 psi sensor. So that's all good. And then if we go lastly to temperatures and we go to oil temp sensor, we actually had to make a custom graph. So Amazon, I bought the sensor from Amazon, and it was like a 3-star sensor. I only bought it because it was the only 2-wire sensor I could find, and I'm anal. But this guy here has this equation. So what we did was we basically used that equation to calculate what ohms correspond to what temperature in Fahrenheit. Copied that, pasted it into here. So this graph is all good. That's a custom graph right there. And yeah, that's pretty much it. All right, y'all, that smoke is not cigar smoke. We ran the car a little bit. Carbon monoxide is slowly going down. That's what happens when you run your car indoors. But the good news is it works. It all works. So let's show you what's going on here. So this is the saved session from when I ran the car and stunk up my garage. You'll see a graph of some data here. This beige line, that's the fuel pressure. So we started out at like 65 or so. I turned the adjuster knob, it went down to 61. I turned the adjuster knob some more, went down to 59. But basically, we need to lower that. It should be somewhere around 45. We'll take care of it when we go to the tuner. The other thing we need to take care of is this AFR. So the AFR was really high, really lean, and I realized that I didn't have my lambda feedback enabled. So you can see it's right there. I had to turn that on. And then what ended up happening was it corrected. But that also tells me that the base maps might be way off, which they appear to be very much so, because the volumetric efficiency is like 112 right here, and this is a naturally aspirated motor. But that's what the base map was set to, so when we take it to the tuner, we will have them fix that. You don't want too much lambda correction to compensate for a bad map. It's just no bueno. And then over here, you can see we have working pressures and temperatures. So oil temp is the block temp. Oil pressure is oil pressure. We got coolant pressure. There was no coolant in the car for this test. And then again, fuel pressure. So that means we can continue wrapping up this harness. But I think I'm going to wrap up the video here, actually, folks, because it's been a long video. I got to get more coolant in this thing now because it has no coolant in it. And then finish up that harness, and it seems to run, get all the data that we need. It even has redundant water temperature. It's pretty fancy. And water pressure. Also pretty fancy. We're getting more and more advanced with this car. More things are done. And I hope y'all are enjoying this, man. It is certainly a project. Until the next time, make sure you follow the channel, give me a subscribe, like this video, and share it with your friends. Appreciate y'all watching. Peace out.